This command will take you through the steps for design regrade to do reclamation design on this high wall. We'll start by looking at the surface in the 3D viewer surface file. I've got this Regrade topo grid file, and if you zoom in to check it out, you'll see this existing high wall. So we'll use this design regrade tool in cross section to cut and fill into this existing empty pit. First step would be to draw the section alignment, so I'll just draw a polyline, the length of the cross sections you'd like to create, and then create the section alignment. So I will go to Sections, Input Edit, Section Alignment, and we'll make a new one called Regrade Topo. Pick my polyline, starting at station 0. I will do 500 interval and 500 left and right. Save and exit. So this gives you a preview of the polylines, and there's 5 existing cross-section polylines for this section alignment. Now I'll create the section file with sections from grid or triangulation. And I'll choose the grid file and choose the alignment file for the position of the cross sections, and then finally I'll pick the section file itself. We'll call it existing topo. Now we can draw the cross sections with draw section file. Choose that file called existing topo, and I'll scan file to set defaults. Every grid will be starting at 1350 bottom elevation. Turn off fit each vertical grid. That allows the option for setting the elevation. Hit OK and pick the location for the cross sections. Now the command design regrade is found under sections, design regrade. And let's start with the bottom elevation, 1350. No vertical exaggeration, they're all 100, 100. I'll make a new file, and let's call this regrade output. This is an output cross-section file, and also we'll do a new earthworks file to calculate the volume. Regrade output as well. Okay, and then you start the first cross section. It wants the center point of the grid, which is your 0 offset. Object snap comes on to allow you to select that point, and then you choose the existing surface, grade polyline, and then you work from left to right, picking the new surface that you're grading to, keeping track of your slope in the top right corner, and also the cut fill numbers. That's a square, that's an area, and then when you convert to 3D it will be converted to volume. So I'll now do some fill and then come over and do some more cut, and then you can always go back and change some existing ground object snap right there to the red line. Alright, so now if you look at my polyline in the top right, you'll see I've got too much cut, so I'll need to raise that up. You can hit M for modify and then go back and change a point. And I'll modify again. Let's give it a little bit more fill in the middle, and I'll just enter to end the command. Pick a point for label. Enter station. It's looking for this station, 0. Okay, 1 down. I've got 4 to go. Come down and do it again. I've got my same bottom elevation. My swell factor is 1.2. And hit OK. Pick the next center point, which is station 500. Pick the existing grade polyline, and I'll just start on the lower left, upper left I should say, and then do your cut, and then fill into the empty pit. Come over to the right and do a little bit more cut. And I'll just modify some of the middle points to get the cut fill balance. Enter to end and label. Enter station 500. Okay, next one. center point, existing grade, and work from left to right. We'll just do 2 more after this and then get into processing these to 3D and getting the volume of this material. And got way too much cut on that one, so I'll modify it and bring this up. And bring up the fill point as well. Enter to end and place the position. So it's also helpful if you have other surfaces on here, like a reclamation or post-mine surface topography, or any of your geological surface files could be added to these cross sections to aid you in placing the new green line that you see there, which is my regrade surface. Put in station 1000, and I have 2 to go, and then we'll go into 3D. Pick the center point, which is this at 1500. Existing ground line, lower left. Come through and do some fill, and then rejoin over on the right side. And then modify to balance the cut fill if they're not. And that one's pretty close, so I'll just enter to end. And that's station 1500. Pick point for label, 1500. And the last cross section. So once you get the feel for this command, you can get through it pretty fast. All these cross sections. This is station 1950.55. Existing ground, and then just start tracing your earthwork polyline. This is a section now, will be converted to 3D surface here very soon. It's a good idea to tie those endpoints to the existing surface if you can. Again, I'm just going through this fairly fast for the movie presentation. Getting a fairly close cut fill balance, but not as good as you'd like. Point for label, end station is 1950.55. Enter. Alright, so that's done. We've made the section file. Now a couple of things we'll do will be to calculate the volume of that material. So we're going to run under sections and do the very last command, edit process end area file. I have an EW for earthworks file. If I open that, there's my 5 cross sections. I'll just hit report. We'll do the standard report, and that shows us the total cut and the total fill in volume. Also, it shows you station by station cross sections up above. So it's close to a balance, but again, you can get better than that when you go slower and you're trying for more accuracy instead of speed for the movie. Next step will be to take those lines, these green polylines I just drew, and place them over in 3D in the map, and then make a new surface. The command for that is under sections, down under section utilities. It's called sections to 3D polylines. It'll put them on this new layer, and I'll just choose the polyline as my alignment method, which is this green polyline in the map view. Okay, choose the section file to draw, which is regrade output, from 0 to 1950.55. Okay, that works. Draw cross sections only. Pick your polyline, starting station 0, and it's just, if you had a curve, it'd be a road. Draw perimeter of sections, yes. Reduce vertices, no. Alright, so there we have the output of the cross sections. And then to create the 3D surface, what I will do is isolate that layer. And then we'll run the command triangulate and contour. We'll do 2 things here. What we'll do is draw the triangle faces and also write the triangulation tint file, call it regrade output. And let's even contour it. We'll put a contour interval in there of 10 feet or 10 meters. And we'll make that on layer contour regrade. And we'll even use this as our inclusion. No exclusion. And select the items to contour. And then restore the layers. And then if we pull this whole thing into the Carlson viewer from the drawing, and we'll just grab all 3D entities and turn off color by elevation to see the result. The red contours were the original. The light blue contours with the magenta triangle faces is the new regrade. And you can see the difference as you slice and peel away using this clipping plane. There's a difference between the two surfaces. And then one more check for volume calculation. If we run, we have a tin file of this surface, we have a grid file of the topo. One thing to do to convert a grid to a tin so we can compare two tins would be just to select the surface topo, export that grid out as a triangulation file. That will give us two tins to compare. And we'll call this existing surface. Next we'll go to surface, volumes by triangulation, to triangulation surface volume. The first one is existing ground. The output is the final. Pick that same inclusion boundary, which is a little difficult to get to, so let's turn on the selection cycling down below. That way when you pick on the perimeter, it grabs the proper polyline. And just get the volume and the area. And there's the same volume. This is now swelled. Before it was not swelled. So now I've got the cut volume overall and the fill volume overall. And then the two surfaces can be viewed together. One last time, if you go to View, 3D View, Surface File. Next we'll grab the new surface called Regrade Output. And so here you can see the various cut and fills we just used the design regrade for. And then let's use the clipping plane to erase in front. And there you can see cut and fill. One surface, the yellow surface is below the ground here and above the ground there. So those are the steps to use the design regrade tool within Carlson Civil to do balanced cut fill design on section and convert it to a 3D surface for volume calculation. Finally, we'll show how to trim out the old contours and bring in and join the new contours with the previous contour set. So first I will freeze these triangle faces. And then let's go ahead and change the color of those new contours so they stand out a little better. Make them dark blue, for example. And then I'll need to isolate this perimeter. So I have one called 3D cross section. I need to isolate that perimeter. I'll just make an exact copy of it into a new layer. Let's call it copy to layer. Pick my boundary. And I'll just call it perimeter. Okay, and then I can freeze the 3D cross section layer. So there's my perimeter, and I'll also freeze the new contours for now. And let's get rid of that so we don't destroy or delete that perimeter line. Now there's two ways to get rid of these contours. You can simply erase by closed. If you didn't need them in the drawing, you can run erase by closed polyline to delete them inside. If you want to keep them, then you'll have to go to break. That's edit, break, by crossing polyline. Pick the crossing clipping edge polyline, and then right away it says select all the objects to break or to clip. Specify layer inside, I'll say yes, and let's call them trimmed contours. Specify layer outside is no. And now you can see they're broken at that perimeter, and so I'm allowed to just freeze those. And then let's go get the other contours, the regrade, and bring them back on. So that's how you would merge and join one surface contour map from another, and there's my final regrade surface. So this completes the design regrade using the civil module for reclamation design, taking cross sections, balancing the cut fill earthwork, converting back to 3D surfaces, and calculating volumes. Thank you.